This is Pre-Calculus Math Analysis Unit 11. We're going to be talking about limits and derivatives. We want to understand the concept of limits as well as end behavior, explore the difference quotient, and evaluate derivatives. First things first, the definition of a limit. We want to look at functions from both the left and right side. A limit of a function f is the value of f as it approaches, and that is the key word. Some constant that we choose, we'll call it k, from both sides of the function. It is given by LIM as x approaches k of some function, and this is going to be equal to L, where L is usually some number or some constant, and the phrase is x approaches k, where L is in fact the limit. And note that it is possible that a limit doesn't have to exist. How do we evaluate or discover limits if we are not actually plugging in values? Well, we are going to plug in values, but they're just going to be arbitrarily close to whatever that constant is. And we're going to look at that from both sides. Generally, we will pick values that are plus or minus 0.1, plus or minus 0.01, and plus or minus 0.001 from the constant, and complete a table of values. So here is a very, very simple question. Evaluate some function f of x equals x to the third at x equals 1. What we would normally do here is just plug in 1 for x, and the answer is 1 here. The question is going to change when we put in that limit. And it says, evaluate the limit by completing the table of values and drawing the graph of the function. So let's take 0.9 to the third power in order to complete this table. And I'm going to write my answers to the nearest thousandth, so this is going to be 0.729. And then I'm going to take 0.99 to the third power, and that's going to give me an answer of 0.970. And so on. I'm going to fill in this entire table. This is going to be 0.997. And then when I plug in 1.001, I get an answer of 1.003. And then 1.03 and 1.33. So it looks like there's a little bit of a pattern there. It's not unusual. I'll go ahead and graph x to the third. It's going to look something like this. This is the graph of f of x. And it's a continuous function. We have discussed previously that a continuous function has no breaks in it. X to the third is a continuous function. So the limit, as x approaches 1, we can see that 1 is in between 0.999 and 1.001. And as I look at the values from the left and from the right, it looks like it's getting really, really close to 1. So I have to just sort of make the assumption that the closer and closer we get to 1, the limit will approach 1. This is a very straightforward example because if the function is continuous, we can plug in the value. We can plug in the k, which in this case is -1, into the function directly because f is continuous. We don't run into any issues. The next problem, the next type of problem, is a discontinuous function, something that's not continuous. Evaluate the limit by completing the table of values. Round your answers to the nearest thousandth if necessary. So I would like you to, at this point, pause the video, try plugging in 2.9, 2.99, 2.999, and so on into this function and see if you can guess what the limit as x approaches 3 will be. Go ahead. All right. Now, I will do the same exact thing. Plug these values in. You should get 6.8, 6.98, 6.998, and then it's going to jump over 7 to go to 7.002, and then 7.02, 7.2. So if we look in between here, it looks like the function gets to 7. So I think that the limit is going to be 7. If the function is hard to graph, we can do this table of values and figure out the limit algebraically. It's also important to note, we're going to talk about this a little bit later on, but we could analyze this function and say that this is the same as x minus 3 times 2x plus 1 over x minus 3. So that's because the top portion factors, and it turns out that this is going to cancel. And so if we were to just plug in 3, we would get 2 times 3 plus 1, which is equal to 7. So now that is a way to analyze the function with some algebra. So even though we cannot plug in 3, because we would be dividing by 0 and it would not exist, the limit does exist. So that's very important. A function does not have to exist at the point, and the limit can exist. And that brings us to what we would describe as one-sided limits. We can evaluate limits from either side, left or right, of the function if we add a plus or minus to the constant. So I'm going to actually switch this because right is going to be plus, left is going to be minus. K plus, K minus. And we're going to write that as limit as x approaches k minus and limit as x approaches k plus. This is the right-sided or positive limit, positive side. This is going to be the left-sided or negative. You won't always get strictly negative numbers or strictly positive numbers. It's just the way we discuss it. And now we have a theorem. A limit exists if and only if the right-sided, or we'll say the left-sided limit equals the right-sided limit. If that's the case, then we say, therefore, the limit as x approaches k of f of x will equal some number L. This is one of the more important concepts of limits. A limit exists if and only if you approach it from the left side, and then from the right side, it will equal the same L. Let's take a look at an example. Here is a piecewise function. We could write this piecewise function f of x as, well, if it's 1 or greater, then the function is going to be 4. Y equals 4. If it's less than 1, then the function is going to be 2. Y equals 2. So that's the piecewise function we have here. And using that graph, evaluate the limit if it exists. So the limit of the function as x approaches 1 from the right, this is going to be purple. So as we get closer and closer to 1 from the right, we are going to approach 4 because we're on the right side of the function. On the other hand, the limit as x approaches 1 from the left, that means we're on the bottom side of the piecewise function, and so this is going to be equal to 2. And now let's use the theorem. Does limit of 1 plus equal limit of 1 minus? That answer is no, and therefore we have to say that this limit does not exist. The limit does not exist. Please comment on this video in order to earn credit, and then have a nice day.